One of the differentiating characteristics of nanomaterials compared to their corresponding bulk materials is known as the surface-to-volume ratio. As its name suggests, the surface-to-volume ratio describes the relationship between the surface area and the volume of a given object. Nanomaterials have relatively large surface areas while occupying relatively small volumes, resulting in high surface-to-volume ratios. The higher the surface-to-volume ratio, the more atoms are located on the surface of the material, and the smaller the number of core or inner atoms located under the surface. To demonstrate how this works, let's imagine an aluminum cube with side lengths of 10 centimeters. Our 10 centimeter cube has a surface-to-volume ratio of 0.6 reciprocal centimeters. Now imagine we stretch this cube out into a flat square sheet measuring 0.1 millimeters thick. The same volume of material now occupies a much larger surface area. In fact, our sheet has a surface-to-volume ratio of 200 reciprocal centimeters, hundreds of times higher than the same atoms arranged in a cube. If we continued to stretch this sheet until its thickness was at the nanoscale, its surface-to-volume ratio would continue to skyrocket, meaning most of the material is on the surface with very little volume. Carbon nanomaterials provide an extreme example of this. All of the atoms in a buckyball, a single-walled nanotube, or a sheet of graphene are surface atoms. There is no core volume. This is important because the dominance of surface forces is one of the unique characteristics of nanomaterials that gives rise to their novel behaviors and properties. By understanding materials with a high surface-to-volume ratio, we can design the technologies that the world so desperately needs.